we come to high school office.
B squared minus 4AC all over 2. X equals negative B plus or minus the square root. B squared minus 4AC all over 2.
Very good, Aaron.
Wait,
Yeah.
B squared minus 4AC. It's B squared minus 4AC.
okay, started all over.
X equals B plus or minus.
Negative B.
Negative B. Negative B plus or minus the square root of B squared minus 4AC all over 2. I'm trying so hard not to sing it.
Can't do it, Aaron.
I think some of those
So my starters should just say it and sing it.
No. That's terrible.
Now, important to go along with that. You've got the quadratic formula there in your notes. Important to go along with that. We got to remember what the standard form of a quadratic looks like, so we'll know where our A, B, and C come from. Standard form of a quadratic is ax squared plus bx plus c is equal to 0. Okay, so that's where your A, B, and your C come from. I hinted to y'all a little bit about this yesterday, but it's super important to keep in mind today. When you're solving a quadratic, the graph of a quadratic is a parabola. So you're actually finding where your parabola crosses the x-axis. So it's possible for a quadratic to have two solutions because it crosses the x-axis twice. It's possible for a quadratic to have one solution because it just hits the x-axis once. It's possible that a quadratic has no real solutions because it never crosses the x-axis, which would mean they're imaginary, which we'll get into all of that today. Now, solutions is what I say most of the time. They're also called roots. They're also called zeros. So if you're told to find the roots, that just means solve. If you're told to find the zeros, that just means solve. Okay? Ready to just jump in and do one? This is, y'all have always done well on this.
Andrew Mills, Loretta Hudson, and Caitlin Smith, please come to high school office.
I've got 4x squared minus 11x minus 3 is equal to 0. Now, yesterday we did completing the square. Today, the only method I'm going to use is the quadratic formula. After today, we'll have covered completing the square, quadratic formula, and factoring a long time ago. So you'll have any of those methods to choose from. You can pick your favorite. But today, it's all quadratic formula. One huge advantage to the quadratic formula is it works on any type of quadratic. All the rest of them do not. They're pick and choose when they'll work. So first thing we're going to do, I'm going to go through my baby steps on this, and I'm going to label my parts. So what's my A out of this equation? 4, nice. What's my B?
11.
Nope, negative 11, very good. And my C? Negative 3. Okay, a lot of y'all don't have to do that, but make sure we understand where all that comes from. I took for granted that you knew that that equation was in standard form. It was ready to go. It was ax squared bx c. Some of them today we're going to move around and get them ready. Alright, starts off as x equals negative b. We know that negative b just means the opposite sign of our b. So when I write x equals negative b, my b is a negative 11. So the opposite of a negative 11 is a positive 11. So we got x equals negative b, that's positive 11, plus or minus the square root of. Now here's one of my biggest pet peeves about the quadratic formula, not overall, just about the quadratic formula. The first thing underneath that radical will always be a positive number because you're squaring it. B squared, isn't that what the song said? B squared, you're squaring it. That means a number times itself. A positive times a positive is a positive. A negative times a negative is also a positive. You would be surprised how many people will put a negative 121 there and then they'll miss the whole thing. It's negative 11 times negative 11, which is a positive 121. If you can't do that in your head and you depend on your calculator, you got to make sure you put the negative 11 in parentheses. Okay? So don't forget that and mess up there. That first part should always be a positive. Alright, so we've got negative b plus or minus the square root of b squared minus 4. It's always a 4. Times a times c all over 2. It's always a 2 times a. So now it's just basic calculations, and different people attack it different ways. Some try to do too much at one time and they end up messing up. It's you can do it however you want as long as you're careful and make sure you get it right. I'm obviously working it, so I'm going to work it the way I would. First thing I would see is that I got a negative times a negative, so that's going to turn to a positive, so I'm going to be adding something. Okay, so after I've discovered that, I don't even care about the signs anymore. I know whatever I get when I multiply those digits, I'm going to add it to 121. It's going to be a positive because of a negative times a negative. So I've got 4 times 4 is 16. You following that? 4 times 4 is 16. 16 times 3 is 48. So underneath that radical, I got 121 plus 48. What's 121 plus 48?
169.
Thank you, sir, Dustin. All over 8. Now started off pretty friendly on this one because 169 is a perfect square. What times itself is 169? That was right. Say it again. 13. Nice job. So here we've got 11 plus or minus 13 divided by 8. Now a lot of people will get here and stop, and that is way wrong. If this was not all good, plain, real numbers, rational numbers, we might be able to stop if there was a square root or something. But we got to figure this out, work this 2 times. That's what your plus minus says. So we got to do 11 plus 13 and divide it by 8. And we got to do 11 minus 13 and divide it by 8. That's what the plus minus means there. 11 plus 13 is 24. Divided by 8 gets me a 3. 11 minus 13 is negative 2. Divided by 8 gets me a negative 1/4.
What did you say about the negatives right here?
Since I had a negative times a negative, I knew that whole chunk was going to turn positive. Alright, nothing too bad, nothing too hard. Y'all are good at this in Algebra 2. You're still going to be good at it. This one says 2x squared, as soon as my page on here turns over, 2x squared plus 19 is equal to 14x. 2x squared plus 19 is equal to 14x. Uh-oh, gotta do something here.
Subtract.
Good. What are we doing? And Custom's right, we're going to subtract 14x. What's a mathematical phrase that describes why we're doing that? Say what, Willis? Oh, I didn't hear what you said, honestly.
Michael forgot.
What's ax squared plus bx plus c? What did I say that was called? It is quadratic, but I gave you a specific on it. Standard form of a quadratic. So when Keston did the right thing and subtracted that 14x, she's putting it into standard form. Okay, how that says mathematically.
Gotcha.
2x squared, x comes next, so I'm going to put her minus 14x next. Now we're good, we're in standard form, so we can label our A, B, and C. Okay, what's your A? Just a 2, just take a coefficient, but you're in the right spot, I like it. What's your B? Negative, take the sign with it. Negative 14, you're on. C, 19, there we go. Everybody all right? Plug them in. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Alright, what I was talking to Grace about just a second ago, on that previous problem, we had negative 4 and then times another negative. So that negative times a negative made a positive. But right now I got negative 4 and there's not another negative. So that's going to end up being 196 minus right there, right? Because you just had the one negative. 4 times 2 is 8. 8 times 19. Anybody know what 8 times 19 is? 152. Is that right? So I got to figure out what 196 minus 152 is. 44. Should I get a 44 underneath the radical? So I got x is 14 plus or minus the square root of 44 all over 4. Now, on the last problem, we got a 169 underneath there. That's a nice number because it's a perfect square. 44 is not a perfect square. So what we've been doing the last few days, we got to break it down. What's the biggest perfect square that'll go evenly into 44?
4.
4. Very good. Kaylee's got that. 44 is the same as 4 times 11. So you rewrite that as the square root of 4 times 11. Square root of 4 is 2. So we're going to bring that 2 out. So we're looking at x equals 14 plus or minus 2 square roots of 11 all over 4. Sometimes I'll circle that, sometimes I won't. Will I this time? Is that it? Am I done? Am I done here?
Yeah.
No. I mean,
14, 2, and 4. Those are all evens. I can reduce all of those, right? So divide them all by 2. I have x is 7 plus or minus 1 square root of 11 all over 2.
Then you circle it.
And you circle it. Now, first period, I thought this was a pretty simple lower level question, and first period blew it. How many answers did I circle there? 2. Very good. Because I got 7 plus the square root of 11 divided by 2. And I got 7 minus the square root of 11 divided by 2. They thought I wrote it in all one hunk. That meant one answer. Okay, if you see it that way, then you need to write that out twice like I just read it. Write 7 plus the square root of 11 over 2 and 7 minus the square root of 11 over 2. Plus minus gives you those 2 answers there. Alright, I got x plus 5 times x plus 1 is equal to 10x. If, big capital I, capital F here, if that had said equals 0, I'd know the answers and I'd be done. Because I could just set those factors equal to 0 and solve. But it doesn't. Dad nabbit says equals 10x. So we got a lot of work to do. Like we were talking about a second ago, we got to try to get that into standard form. How would we start attacking to make that look like standard form?
FOIL.
Very good. We got 2 binomials. Kelly is going to FOIL. So I got an x squared. I'm going to try to skip a step here. Outer is 1x. Inner is 5x. That's a total of 6x. And then last is 5. It is close to standard form now, but it's still not there. Good, good, Chase. Good, Grace. Subtract that 10x. So I got x squared minus 4x plus 5 equals 0. Y'all sat through enough math with me to know that my favorite way of solving a quadratic is factoring. And I got really excited at first thinking this one could factor. Because I looked at my a times c and I had a 5. But there are no factors of 5 that add to negative 4. 1 and 5 adds to 6. Negative 1 and negative 5 adds to negative 6. So I got excited for no reason. I got to do the quadratic formula. I'm labeling A as 1. B is negative 4. And C is 5. Alright, you ready? X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Now, some of us are noticing something's changed already in how my answer is going to look here. Any guesses?
It's going to have an I.
Very good, Kaylee. I'm looking at 16 minus 20, right? That's simple mental math. Y'all ought to be able to do that. 16, 4 times 1 is 5 is 20. 16 minus 20. So I'm going to have a negative underneath the radical, which means this is going to have imaginary. So 16 minus 20 is negative 4. So I got x is 4 plus or minus the square root of negative 4. 4 won't work very good there. All over 2. What's the square root of negative 4?
4I, or 2I.
2i. Very good. Square root of 4 is 2. The negative is an I. So we got x is 4 plus or minus 2I divided by 2.
Reduce it.
Very good. Zane's not letting me circle yet because we've got to reduce that dude. Divide them both by 2. X is 2 plus or minus 1I. Alright, every now and then we'll get a question that doesn't ask for the solutions. It asks how many and what kind of solutions there are. If that's the case, you could do the whole quadratic formula and figure that out, but that would be more work than necessary. What's called the discriminant will tell us how many and what kind of solutions. The discriminant you already know. It's the part of the quadratic formula that is underneath the radical. So you only have to do that part. Now how you figure it out, if you work out the b squared minus 4ac and your answer is positive, which means bigger than 0, you're going to have 2 real solutions. If you work out the discriminant and you get a negative, which means your answer is less than 0, you're going to have 2 non-real, or what's a non-real called?
Imaginary.
Imaginary. You can put that if you would prefer. One more option, if we work out our discriminant and we get exactly 0, we're going to have 1 real solution. Okay, so I'm going to work a couple, 1 or 2 of the 3 of those with you. Got what you need on that note page? Now we can get on the real, the greater than 0, we can get even more specific and tell if they're going to be rational or not, meaning if they're going to be perfect squares or not, and I'll talk to you about that when we see that. Alright, so here I've got 10x squared minus x minus 2. The directions say tell the number and type of solutions. So it doesn't say solve, so I don't care what they are, I want to know how many and what kind. So I'm going to take the shortcut and just do the discriminant. So my A will be 10, my B will be negative 1, and my C will be negative 2. B squared, negative 1 squared is 1, minus 4 times A times C. Now I can look at that and already know I'm going to have a positive number because I got a negative times a negative, which is a positive. So I already know there's going to be 2 real. But let's go ahead and work this thing out and see what we got. 4 times 10 is 40, times 2 is 80, so I got 1 plus 80, so I ended up getting 81. So think about the whole big quadratic formula. 81 would be the part underneath the radical. Is that a perfect square? So that means those 2 real, Zane's right, that means those 2 real solutions are also going to be rational. It means you won't have a square root symbol left in your answer. If that had came out like 80, which is not a perfect square, they would be irrational. Does that make a little bit of sense? Okay, let's try another couple of those. I got it? Here I've got 3x squared minus x equals 7. Directions are the same. Tell the number and type of solutions. This one's got some preliminary work to be done. Good. Chase, subtract the 7. So I have 3x squared minus x minus 7 is equal to 0, which means I got an A of 3, a B of negative 1, and a C of negative 7. So I got negative B, oh, hold on, we're just doing the discriminant. B squared, negative 1 squared is 1, minus 4 times A times C. Now again, I say this one's going to be positive because I got a negative times a negative, so I know I'm going to have 2 real. Only thing left to find is are they going to be rational or irrational. Well, 4 times 3 is 12. 12 times 7 is 84, so I got 1 plus 84. So what about 85?
No.
Good, Zane. That's not a perfect square. So my 2 real solutions will be irrational, meaning I'm going to have a square root in my answer. Alright, I got one more of those. Hang in there, one more. Alright, this one says 16x squared plus 25 is equal to 40x. Directions are the same. Tell how many and what kind of solutions. Preliminary work. Do we need to do anything here? Yep. Move that 40x. Nice job. 16x squared minus 40x plus 25 is equal to 0. So I got an A of 16, a B of negative 40, and a C of 25. Alright, B squared, negative 40 squared, 1600 minus 4 times A times C. Okay, I know I'm subtracting here, so I don't know what 4 times 16 is off the top of my head, but I do know 4 times 25 is 100, so then get that 16 there and I'll get 1600. So I'm looking at 1600 minus 1600. So I got a discriminant of 0. What did we say a discriminant equal to 0 told us about our answers? 1 real, very good. And we don't have to decide about if they're rational or not. Right. Alright, nice job on that. Fixing to have a spot to answer this exit question, and this one is a solution one. Want to know the solutions. Find that one I did that I liked earlier. Yeah, we'll do that one. Alright. Solve is the directions. I'm not asking for the discriminant. 2x squared plus 4x plus 1 is equal to 0. Alright, it showed up in mine, so you might need to refresh yours.